In this question, we are given a triangle with vertices at PQR, where PQR are specific points given to us in XY coordinate notation. And the question requires us to calculate the circumcenter of this triangle. Now, we have seen a few circumcenter questions in the playlist on Edexcel Year 1 Pure Challenge problems. So the question you must be thinking to yourself is, why is another circumcenter question being covered? So in the past, we've gone to full details and we've actually reasoned comprehensively using diagrams and using geometry and also using quite heavy algebra to get an answer and also to check an answer, right? But in this case, we're not going to do that. In this case, we're basically going to arrive at an analytic solution. In other words, we're going to do minimum work. And this is the sort of thing that you're really expected to do in an exam situation. All right, so what are we going to do? So we know what a circumcenter is. A circumcenter is basically a point at which the perpendicular bisectors to the three sides of the triangle are actually going to meet, right? But because we're going to do minimum work, we're not going to work with three sides of the triangle. We don't need to. We only need to consider two sides of the triangle to be able to work out a point of intersection. So I'm going to define my line L1 and L2, where L1 is the perpendicular bisector of the side PQ and L2 is the perpendicular bisector of the side QR. In this case, I have chosen to go with the side PQ of a triangle and the other side being QR because when I work out the midpoints, because I have to satisfy the bisector part of this condition, when I work out the midpoint of PQ works out to be a relatively nice number, and so does the midpoint of the point QR. Okay, so in an exam situation, make sure you look at your points carefully and sort of make an active choice as to which pair of points will actually give you easier numbers to work with. All right, so what are we going to do? We're going to have to work out perpendicular bisectors. So the first thing we might want to do is actually work out the midpoint, right? That would satisfy the bisector part of the condition. And we work out the midpoint using the midpoint formula, which is you add up the corresponding x coordinates and you divide by 2. So 6 plus 3 is 9, divided by 2 is 9 over 2. And then you add up the corresponding y coordinates and you divide by 2. So 9 plus minus 3 is 6. So I have that 6 divided by 2. And obviously this simplifies to give me 9 over 2, 3 as the point. And I will leave you to check the details for QR. We've done literally the same thing here. So now that we have the midpoints, we're going to have to figure out gradients because we want a perpendicular bisector. So we want a line, in other words. So we're going to have to figure out the gradient of segments PQ and segments QR, right? And again, we're going to apply the change in y over change in x formula. So my x1, y1 is 6, 9. My x2, y2 is 3 minus 3. So y2 minus y1 is minus 3 minus 9. That checks out. And then x2 minus x1 is 3 minus 6. That also checks out. And that simplifies to give me 4. Again, I will leave you to check that the gradient of the segment QR is actually minus a half. But in each case, once we've got the gradient of our segments, PQ and QR respectively, we want perpendiculars to them, right? So we're going to have to flip this. This 4 can be thought of as 4 over 1. When I flip it, I get a quarter, and we stick a negative in front by the perpendicular gradient property. And similarly, I've got a half here. I flip it, I get 2. And then I stick a negative in front, which means this negative would go away, and I'll end up with 2. So we've got a point and we've got a gradient for our perpendicular bisector of PQ. And we've also got a point and we've got a gradient for our perpendicular bisector of the point QR. So we're going to write down the equation of the line L1, in other words, the line we're looking for. The y-intercept is as yet unknown, and so what we're going to do is we're going to use this point here, 9 over 2, 3, and stick in x equals 9 over 2 and y equals 3 to be able to get this equation, which we can then solve to be able to get the c value, or the value of c1 at least. And on the right-hand side here, what's basically happening is the exact same thing as what's happened on the left-hand side, but feel free to pause the video and check the details that this actually makes sense. So now that we actually have the y-intercept in both cases, we can write down the equation of the two lines in both cases. So our L1, the perpendicular to PQ, is this equation, and our L2, the perpendicular to QR, is this equation. So to find the circumcenter, we will just solve these two simultaneously. And we can do this fairly easily by just setting the two y's to be equal to one another, which means I'll have this expression here equals to 2x plus 6, which is what I have here. And at this stage, it's sensible to multiply through by 8, which will get rid of the fractions here. So multiplying a quarter by 8 would give me 2. Obviously, the minus would stay because we had that initially. And then we chose 8 because we wanted to get rid of 33 over 8 as a fraction. So multiplying by 8 will just give me 33. And 8 times 2 is 16. And 6 times 8 is 48. So this is completely sensible. So the minus 2 now goes to the right-hand side, combines with the 16 to give me the 18. And then the 33 remains on the left and the 48 remains on the right. But now we can take the 48 to the left, and that gives me minus 15. So we solve this by dividing both sides by 18. So x equals minus 15 over 18, which simplifies because both of these are in the 3 times table to give me minus 5/6. I can put that x value into either one of these equations. This equation is in terms of whole numbers, so it's nicer, so I'm going to go for this one. So I'm just going to replace this x by minus 5/6. I do that. We crunch through the numbers, and out pops 13 over 3, which means that actually our circumcenter of the triangle PQR is at this point, okay? And so we've managed to answer this question with, quite frankly, the least amount of work that we had to do. Again, if this does not make sense, then feel free to go back and look at some more videos that we've done on Circumcenter, which are more thorough. But otherwise, thanks for watching, and if you found this useful, then do consider subscribing.